Take a moment to look at a seashell. Its smooth, spiraling curve seems almost too perfect to be natural. But that elegant swirl follows a hidden mathematical pattern known as the Fibonacci sequence. Now imagine the center of a sunflower. See how the seeds form spirals in both directions, clockwise and counterclockwise? If you count them, you usually find the Fibonacci numbers, like 34 and 55. These spirals help the seeds be packed in the most efficient way possible. Perfect balance of beauty and mathematics. Welcome to today's video. In this one, we'll be exploring the Fibonacci sequence in nature. So, let's get right into the video. But what is the Fibonacci sequence? It's an infinite series of numbers where each number is the sum of the two preceding ones.
Damn! It usually starts with a 0, then followed by a 1, another 1, a 2, a 3, a 5, an 8, 13, and so on, infinitely.
But why is it so special? Let's say we get two numbers, 21 for example, and the one before it, 13. So we do 21 divided by 13, which equals 1.615. And then if we get 34 and we divide it by 21, we get 34 by 21 equals 1.619. If we keep doing this operation, getting one number and dividing it by the one before it, we'll approach this letter right here, called phi. It's a Greek letter that represents the golden ratio, which is 1.618. And as we can see, these divisions converge to this number. They are approximating to 1.618. But why is this so important? This golden ratio is so important because it shows up in places where efficiency, patterns, and precision really matter. In nature, it helps plants grow in the most efficient way in order to maximize sunlight and space. In art and architecture, it creates proportions that people have found visually pleasing for centuries, from the Parthenon in Greece to the works of the famous Leonardo da Vinci. Even galaxies and hurricanes follow this pattern linked to the golden ratio. It's like nature's favorite blueprint. Simple, elegant, and endlessly beautiful. But all of this wouldn't have been possible without this guy, Leonardo Fibonacci, who lived 80 years. From 1170 to 1250 after Christ, also known as Leonardo of Pisa. Fibonacci introduces his sequence to the Western world in a book called Liber Abaci in 1202 after Christ. However, Fibonacci didn't invent the sequence. Versions of it appeared earlier in Indian mathematics. What he actually did was use this sequence and apply it to a rabbit population problem that made it widely known across the whole Europe. So that was today's video. I hope you guys enjoyed this one about Fibonacci and how it's linked to nature, and I'll catch you all in the next one. Peace out.